Okay, today let's discuss the dealing with materials data collection analysis and interpretation course assignment number 5. So straight away we'll go with question number 1. So the question is suppose a small machine component is produced by a certain company. It has a probability of getting being defect is 0.005 per 5, which is relatively very less. So the company ships this machine component in a lot of 25. Which of the following OR snippet calculates the probability that a randomly chosen lot containing exactly one defective component? Okay. Before going into the options, let me go through all the functions and their purpose. So D binom. This just remember this is going to be same for all the other distributions as well. D represents like exactly for that particular observation. For example, here they have given exactly one defective, to exactly two defective, exactly five defective. For that, if we want to find, it is D binom. Binom represents a binomial distribution because here the defect defect is relatively considerable, and defect probability I'm telling, and machine okay, the number of components is also finite, so we can use the binomial distribution. So so we are using binomial distribution here. So d binom, d is for only one observation, exactly one defect, or exactly two defect, exactly n number of defects. So for that we can use the d binom. For p binom, okay, we can see one example. Calculate the probability of getting exactly, means exactly two heads in 5 coin tosses. So if you see the syntax, x is the number of success in next is n trials. So how much ever trials we have conducted, we have to give here. Then probability of success in each trial. What is the probability of success in each trial we have to give? So we can see this with an example. So calculate the probability of getting two heads in 5 coin tosses. So d binom, number of success in n trials. Number of successes 2, trials is 5. So probability of success to get heads in each trial is 0.5. For example, if you want to check for the probability of getting 5 in uh, uh, 6 dice throw is 6 dice throw means we can give 4 comma 6 comma probability is 1 by 6. Yeah, because the probability of getting 4, um, number 4 in a trial is 1 by 6 in die, while throwing a die. So next we will go with the p binom. P binom is used to calculate the cumulative distributive function. So here you can tell at least one defect, which means like it can be zero defect or one defect. If you tell at least sorry, I made a mistake here. So at most one defect means it can be like zero or one, not more than one. So that is at most. If you are telling at least one means it can be like n number. It can be one or more number of defects. So for that only we are using the CDF function. You can see similarly like D binom, here also P binom x comma n comma probability of success in each trial. So x is the number of success in n trials. So you can see with an example, calculate the probability of getting 2 or fewer heads in 5 coin tosses. It's like utmost condition here. So 2 or fewer means it can be 0, 1 or 2. So by P binom of 2 comma 5 comma probability is equal to 0.5, it will return the probability of getting at most 2 heads in 5 coin tosses. So Q binom is used to calculate the quantiles of a binomial distribution. For example, if you have a um, if you have this quantiles we can more frequently see in this CAT examinations where number of people getting 95 percentiles. So to calculate that, we can give like percentile is 0.95, which is 95 percentile is 0.95 here, and size is equal to how much our people they are writing. Let's take each one represents 1 lakh, so 20 means 20 lakhs. Then probability of success for probability of people getting that more than 95 percentile or 95 percentile is 0.3. So it returns the value like the probability of success in each exam is point in a CAT exam is 0.3, and it will return how much people have scored more than 95 percentile. Yeah. So for percentile and quantile calculations, we can use the Q binom. Yeah. So R binom is somewhat different compared to other whatever we have discussed, because generally what we will do, we will have a data. From that we will be generating the parameters like mean, median, everything, and then we will be using it in to form a PMF or any functions. But here if you see, you will have a distribution in mind, and you have what is a deviation, and what is a range, everything. So but you don't have the numbers. So for that we can use R binom and generate the binomial distribution or normal distribution. For normal distribution is n norm. So n norm. So it gives the random variables. It gives the random values in a given interval for a given distribution. So here binomial distribution. So for example, generate 10 random variables from a binary distribution with 5 trials and probability of success is 0.3. So our binomial is like we need 10 random variables from a number of trials 5 with a probability of 0.3. Okay, so coming back to the question number 1, like what could be the answer for the question number 1? Here they are asking exactly one defective, which means like we need only probability of getting one defect. That time, as we discussed, D binom is a proper code for this syntax to get the desired result. So, but in case of question number 2, we can see if you want to calculate the probability of at most one defective component, which means like it can have less than one also in randomly chosen lot. So at that time, we can use this cumulative distribution function P binom. So let's go to the next question. So third question is in an atom probe analysis, atom gets knocked off from the specimen surface and are detected by a radial detector in the setup. During this process, let us assume that m atoms are knocked. So total number of atoms knocked off is m. Out of m atoms, only n atoms are detected. So detector efficiency is n by m. So they are asking the detector efficiency. Okay, one can consider the number of atoms m that gets knocked off from the surface of the real valued random variable denoted by capital M. So it's a random variable M. So it is known as M follows a negative binomial distribution. So parameters n comma q. So they are asking the mean of the random variable M. To calculate the mean, it's like expectation of a random variable. So expected value of random variable M is nothing but n by q. So this is the mean of the random variable. Let's go to the fourth question. In the question number 3, suppose an atom probe detectors an efficiency of 0.6 for detecting an atom. The probability of detecting 100 atoms when 150 atoms have escaped from the surface is. So 150 atoms are evaporated from the surface of the tip, but only 100 atoms are being detected. So they are asking what is the probability of detecting 100 atoms. So again, in binomial distribution, um, here as they have told in the previous one, it is a follows negative binomial distribution, which means like number of trials it has taken to take the first success. It's like detecting 100 atoms, so 100. Number of failures is 50. So from syntax you can see dn binom, which dn d okay, here dn represents the negative binomial distribution. Otherwise it would be only d binom, right? D binom, p binom. Here it is dn binom. N represents a negative distribution. So dm binom of x comma size comma probability. X is the number of failures, so size is the number of trials until the nth success, and probability of success in each trial. So probability of success in each trial is 0.6. So number of trials until success is 100. So here they have asked only detecting 100 atoms. They didn't tell at most or at least like that. So this P won't come into picture. It has to be either of these two. Um, then X is the number of failures. What is the number of failures? 50. 50 atoms could not be detected. So it is 50, 100.6 dn by now. B is the answer for this. So let's go to the fifth question. The hypergeometry distribution can be approximated by binomial distribution. When? Okay, generally for the hypergeometry distribution is calculated without replacement, so we can't change that one. Like what one thing is, when we are increasing the samples, when you are decreasing the sample size to the population, um, the sampling with replacement or without replacement becomes immaterial. How can we tell that? Um okay, we can take an example. You have suppose 70 red balls and 70 red balls and 30 black balls. So this is the population is 100, n is equal to 100 totally in a lot. Then you are sampling only sampling two balls. So now consider what is the probability of getting two red balls with replacement or without replacement. Probability of getting two red balls is like first time when we do it is uh, 70 by 100 with replacement into 70 by 100. Without replacement is 70 by 100 into 69 by 99. This can return 0.49. This returns close to 0.48, 486 or 7, something close to that. So if you approximate, it also comes to 0.49. So now we can see when sample size is very less, um, then this approximation works. And so we can consider the hypergeometric distribution can be binomial distribution, because with replacement or without replacement becomes immaterial because both the values are close. So sample size is very small compared to population, and even when sampling is done without replacement, as like an hypergeometric distribution, it won't affect the result when size of the sample size is less compared to the population size. Let's go to sixth question. So suppose an urn contains 70 white balls and 3 black balls. Okay. So what is the probability of getting 14 white balls from the sample of 20 balls taken from the urn? So here they have told, they have given from the options we can see they are using hypergeometric distributions to solve this. So what is the syntax for d hyper? D hyper means exactly like what is the probability of getting 14 white balls here? Like it's the exact. It's not a cumulative or cumulative to find the CDF function. So this D hyper is ruled out. It's either A or C. So now if you see here, um, in the D hyper syntax, you can see X is the value at which to evaluate the PMF. So here the what is the probability of selecting 14 white balls? So that is 14 is the X value. then M is the success of number of success in the population. So here 70 is the success. 70 white balls can become a success. And failure is when we get black balls, it's a failure. So 30 failure. So sample sizes we are sampling 14. Sorry, we are sampling 20 balls. So if you plug in these things to here, like A is the correct answer. Here C is also close to correct answer when this becomes 30. So become correct answer. Let's come to the seventh question. Let f of x be a cumulative distribution function, then median can be written as. So for cumulative distribution functions, median is the one which is dividing the range into half. For that, if you are finding f of some value median, the CDF will return the value as capital F tells the CDF function. So f of the cumulative distribution of median function gives 0.5. So when you want to find the median value, then you have to take inverse. So it is f inverse of 0.5. So correct answer is A. Coming to the eighth question. Eighth question is the probability of n nucleation events in an uncooled liquid melt containing n nuclei follows the Poisson distribution. So so here 8 nucleation events can occur on an average in a system with 100 nuclei. So number of rate of which the nucleation happens is lambda. This is generally like for Poisson distribution. The lambda rate is 8. And they are asking what is the probability at least 12 nucleation event has already occurred. The event have occurred. So for that, first they have already told it's a Poisson distribution. So and at least 12. So if they have asked for exactly 12, then we can directly use a deep POIS to find the exact probability. Here they have used only they have asked at least 12, which can be like which can be like 12 or more, up to 100 can occur. So if you are using the pen and paper, it will become difficult because like you have to find the probability for 12, then 13, then up to 100 you have to find. But luckily with the help of R, we can just um, write one line code and we can get the answer out of it. So how we can do it, we will see. So the syntax for that CDF function is in Poisson distribution is PPOIS. Q is the number of events for which the cumulative distribution function has to be calculated. Then lambda is the rate at which the event occurs. Then lower dot tail is the logical value indicating whether to calculate the cumulative probability of x less than a given value or more than the. Okay. Simply the lower tail represents where you want to calculate the CDF below the given Q or above the given Q. Here they have asked for at least 12, which means like above the 12 or above. So that time like lower dot tail is equal to false. But if they have asked like at most 12 means then it's default true. So whenever you want to find at least like more than the given values, then we can use lower dot tail is equal to false. So now we have learned how to make this. So since they have told at least 11, sorry, at least 12. So what we can do is we can calculate um, above 11. So what is the probability of at least 12 increasing that can occur in the system? Okay, at least 12 means it can be more than that also. So one second, let me check the question again. Okay, so it's so they have asked for at least. So what we can do is like we have to take from the range above above 11. So we can plug in the value of x is equal to 11 here, and rate at which it does is 8, and lower tail falls, because like we have to find above. If it is utmost means it would have been like below this, but it is above means so we have to give false. By default it is true. This is the answer. Value corrected to two decimal points is 0.11. So let's go to the ninth question. It's similar. So they're asking what's the average number of accidents that can occur in a junction is 2 accidents per day. The probability that at most 50 accidents in a month of 30 days is given by. So at most means it can be like 50 or less than that. So for that, what we can do is yeah, for that what we can do is like, first we have to calculate what is the average number of accidents that is happening in a year, sorry, in a month of 30 days. For that, we just have to multiply the number of days and average number of accidents per day. So it is 30 into 2, so 60 accidents is are happening per month. It's a rate. So as we have seen before, lambda is 60 here, and q is they have already given 50. So q lambda, and lower tail is by default it is true. Here also they are asking for utmost, which means like less than that. So we need not specify it explicitly. By default it is taking the lower tail as true. So it will return the correct answer. So correct answer here is PPOIS, means cumulative distribution from 50 at a rate of 60. So last question, 10th question. In the following R code snippet, if X is the empirical data with mean 10 and standard deviation 2, and Y is a set of random variates with normal distribution. So they are asking us to make a QQ plot uh, where we have to infer some conclusion out of the plot which we are going to obtain. So empirical data is been read and taken to the value x. Empirical data can be from an experiment or simulated data. So y is the generated one. Like we have seen that r binom, here r norm. It's like generating the random values from using normal distribution. Of, okay, 1 second. So first one represents the um, number of values. So 2000 values we are generating at a mean of 10 and the standard deviation of 5. So when we compare these two plots using QQ plot, we can see a linear curve. Both falls in a linear fashion. So when they are linear in fashion, it's intuitive that the given data is following the normal distribution. So yeah, so we have solved all the questions, and if you have further doubts regarding whatever we have solved till now or in the previous assignments, we can mail to the mail ID whatever it is showing now. So I will be ready to clarify the doubts as well. We can have a separate session if you are still having a lot of doubts that yet need to be clear.